Welcome. These are my captures from my conducted field assessment, geologic assessment, that is. And these observations are post Hurricane Melissa. This video is my way of assisting in recovery efforts, albeit in a medium to long term basis. So, Hurricane Melissa, it landed on Jamaica's shores on October 28, 2025 as a Category 5 storm with its strongest winds along the southwestern end and exiting along the northwestern end. Tropical force storm winds were bashing the eastern sections of the island. No parish altogether in Jamaica was spared. Now, this is the first of a series of videos that I, Oshane Brand, intend to make with my geologist hat on, and I intend to share geo-based insight that can be applicable for all residents and non-residents alike. It is geared towards providing sustainable recovery efforts that can be used by policymakers, engineers, etc. The focus area of this video are Skyline, Town, Newcastle Irish Town, and surrounding areas. Now, here are images of the general terrain and the settlement type for the terrain. You can see settlement exists along the fringes of the valley floor as well as the sides of hill slopes. There are also settlement along banks of rivers. Now, this is a Google terrain map, and this gives you a general overview of the areas I covered. And you can see Skyline, Irish Town, Newcastle. General elevation range is 460 meters to above 1,100 meters higher than sea level. Now, why it's important for you to understand elevation is for you basically to have a context of the geohazard risk as well as land use planning, and to provide you with geoengineering guidance, to name a few. Now, here is now the general geology of the focus area of mention. So, upon my observations, I come across, generally speaking, igneous-based rocks, volcanic clastics, and basically the rocks are highly weathered altogether. Now, whilst understanding lithology, it is critical for you to also understand the seismicity. And generally speaking, there exist active fault zones that are relatively nearby to the Newcastle area. Also for you to keep in mind is that the area that I would have covered is highly drained. A lot of water in the context of tributaries and rivers exist. Now, this map is a map that I had created back in 2022, and it highlights basically the major road or thoroughfare, inferred fault zones, as well as drainage point. And this is from Papine, specifically through to Irish Town and Newcastle. And basically, you should be able to see that there exists a lot of blue lines, and these blue lines are basically water flow points, and the dashed lines are the inferred fault zones. So, in essence, this area is highly drained and highly faulted. This image here now, you can see those cracks, and those cracks basically are the joint spaces. And these joint spaces are basically places that the rocks can fail, or in other words, they're like failure points. So, in the context of land slippage, these rocks are major hazards. It is critical for you to also keep in mind that the joint spaces can be further expanded as a result of the action of roots, to name a few. Now, with this image highlighting the volcanic class, it is critical for you to see that these class are highly fractured. And it's also for you to take into consideration that in terms of the building type, there exists properties that are 1 story and can go up to even over 3 stories in height. Now, it is imperative for you to understand that the area that I have covered is highly prone to landslides. And here it is now that I intend to give you some engineering geology specific insight that is applicable to roads, housing, government, commercial properties alike. Now watch this video. This video basically is highlighting the major point of the landslide that has occurred along the main thoroughfare leading to Newcastle. Now take a look at these Google terrain images. Pay attention to the blue dot. The blue dot represents the points of the landslides as I was standing. You can see as I continued my way back down to the Papine area that the areas of landslides slash debris flow are numerous. What I will bring to your attention, and you can link it up when you have the time, is that each of these points where landslides occurred coincides with where drainage flow would also occur. And that basically is highlighted in the maps that I would have created and I have highlighted herein earlier. At this point, we discuss landslide susceptibility. And landslide susceptibility, according to Google AI, is influenced by geologic factors such as slope, elevation, and rock type, as well as topographical factors such as slope, steepness, curvature, and aspect. Environmental factors like rainfall, soil moisture, and vegetation, as well as human factors such as road construction and deforestation, are other key contributors to landslide susceptibility. But there also exist the factors of earthquakes as significant as well. Now, in terms of the geologic and topographical factors, the steepness of the slope is a primary risk factor, with the steeper slopes being more susceptible. Elevation, the height of a location, can be significant, especially in combination with other variables like rainfall. Lithology, the type of rock and soil present, plays a major role in slope stability. Faults and joints, the presence of geologic faults can influence stability, and topography can alter the slope aspect in terms of the direction of the sunlight, to name a few. In terms of the environmental and hydrological factors, heavy or intense rainfall is one of the most common and significant triggers, as it adds weight and can increase pore water pressure. Water, in the form of saturation, whether from rain, stream, or groundwater, can destabilize a slope. Vegetation cover, changes in land cover like deforestation or removal of vegetation, can increase susceptibility by removing the root systems that bind the soil. And erosion, such as caused by rivers, basically can undercut the slope and increase the steepness of the slope. Earthquakes via seismic activity can trigger landslides via the shaking of the ground. Now, taking your attention back to the maps that I had created, And again, pointing your attention specifically to the dash lines and the blue lines. Dash lines being the inferred fault zone lines, blue lines being the drainage points. Highly fractured, highly faulted, highly drained, high elevation, high susceptibility to landslides. Now, in the context of the engineering observations that I would have observed, they include dominantly retaining walls. For residential properties, as you can see in this image, those that exist along the slopes, basically we see the stilts, as I would call them, pretty much being applied. And I interpret those as, the kind of application that goes deep into the slope face to provide a degree of anchor. Now, with this Google AI display as reference, another key element of engineering application towards landslide susceptibility reduction or stability of slope overall is the form of grouting. And this is said to be the injecting of chemical agents or other materials into rock joints and fissures to reinforce the material. Now, with these images, what I am highlighting to you is that even with the implementation of engineering application, it is still not foolproof for landslides to occur. The reality is that over time, engineering reinforcement lose their strength because the whole aspect of time is a critical component. But not only that, weathering, erosion as a key contributors will over time weaken the overall strength of the retaining walls. As well, that you basically should take into consideration that there is subsurface stresses that are being built. So as you can see with this key image here, the retaining wall can be intact, but basically can have landslides that occur underneath and even to the back of the retaining wall. Now, what I want to highlight to you is what the overall lithology looks like. And looking at this landslide here, you can basically see that it is pretty much soil. So it is highly weathered. I want for you to also take into consideration, you can see like those little plate structures underneath the soil. That's the bedrock. And that basically is folded bedrock. And the way the bedrock is dipping towards the face of the slope. Now, you should also can see that it looks kind of smooth. That basically is indicating that it has that kind of a key contributor towards slippage. And this smooth surface as well is basically contributed by the inherent clay minerals. So the breakdown of feldspars basically can yield clay. The presence of mica minerals can be broken down to yield clay. And in the context of landslides now, clay is like the major, like I would say, villain to the engineers who are trying to provide a degree of slope stability. Clay's properties, especially swelling clay, can lead to a high degree of water absorption. It basically can lead to additional pressure being built within the soil. It basically can contribute towards higher levels of plasticity. It can reduce strength of the overall material, and it just pretty much can move the whole, I would say, material or the slope into becoming much more like a liquid. You understand? So clay is pretty much what makes up the majority of the lithology of the areas that I have covered. And this clay is pretty much broken down, or like the product of the igneous rocks being broken down as a result of time, as a result of temperature, as a result of moisture, and even as a result of biologic interference, including humans, to yield clay. Now, other key things you need to keep in mind are angle of repose, which is the maximum angle at which a slope of loose material, such as soil or rock, is stable without sliding. I mentioned poor water pressure, and going further, increased water pressure reduces effective stress holding the soil particles together, decreasing the soil strength. Typically happens due to water from heavy rainfall, and it can even happen as a result of seismic activity. When the water pressure, poor water pressure that is high enough, it can overcome the soil shear strength, causing it to fail and slide. Now remember too, the dip surface, or if you know that the slope is dipping towards, pretty much where the road is, it is going to slide over the road. For your information purposes, as geotechnical engineers, engineering geologists, engineers, and even geologists themselves, triaxial compression or compressive strength is a critical test that's done and is basically a key factor in landslide analysis. By performing this test, engineers can determine the soil strength tests and basically can advise them in terms of how to go forward with their overall engineering plans. Now, the soil plasticity test, as I would have mentioned earlier, is a measure of the soil's ability to form without fracturing, indicating its water absorption and strength. High plasticity basically gives indication to the landslide susceptibility of the material. So, plastic limit, liquid limit, and plasticity index are key, I would say, calculations and or formulas that assist the engineers and other relevant professionals with their overall engineering plans. So at this stage, you should begin to recognize the high degree of technicality that is involved with mitigating and preventing a degree of landslide and pretty much managing landslide susceptibility within a given area. In the context of the plasticity limits, it assists with soil classification. And just for you to just be aware briefly, how engineers will have their soil classification will be somewhat different to how us as geologists will have our soil classification. But in the context of, let's just say, landslide planning overall, there is a degree of correlation. So in that respect, engineers as well as geologists can have an overlap. Hence why there even exists an overlap in the context of engineering geology slash geotechnical or geoengineering as professional fields. Now, going back to the Newcastle reality, what it is that I can say is that, basically speaking, a lot more thorough laboratory and even field work must now be done, because the reality exists that there is fast as well as slow forms of landslides that are taking place. And in this respect, a lot of mapping work, a lot of basically going back to collecting data on a consistent basis, and a lot of development that's also leading towards providing early warning systems that the population themselves can be aware to, as well as that should be adherent to, are critical in terms of managing overall risk. So, having these things in place contribute towards land use planning, as well as the whole context of the fact that there must be resource implementation put in place for continuous monitoring and maintenance for whatever kind of, engineering advice or engineering work that should be put in place for the areas that I would have covered: Skyline, Garden Town, Irish Town, all the way up to Newcastle. Now, the key thing that I want you to gather is that there more than likely is going to be some likely actions that will be taken on the part of engineers, residents, decision makers alike. And these likely considerations are more than likely going to be taken into consideration based on short term, medium term, long term goals. So, encouraging the usage of alternative driving routes to Newcastle JDF base or the Catherine's Peak water plant is a likely consideration. There does exist another route to get to the Newcastle area, albeit this route is highly likely just the same to experience landslides, and it can also experience a degree of similar pretty much failure, whereby the main thoroughfare can become seriously impacted. So, with that being said, it's a race against time, in my view, to ensure that all the necessary engineering implementation that follows the lab tests, that follows the proper consultation with the geoprofessionals are critical in this respect. Now, another likely consideration would be drainage management to reduce surface and subsurface erosion. And I can say that I did observe some drainage pipes that would have been put in place at places where I had observed being, let's just say, tributary points. The thing now is that, in my view, we have to ensure that we again put in whatever kind of drainage management in a very fast manner. Another key thing that I think can occur is the cutting of new roads, which basically means altering the landscape and, in some respects, the slope steepness. And I can also foresee more retaining walls being implemented. This too can be implemented by residents or community personnel alike. Now, in all this that is likely to occur, what I believe we should also consider doing: one, implementing rock bolt and mesh for rock fall locations. And these rock fall locations basically exist along the entire thoroughfare from Garntown all the way up to sections of Newcastle. Another key thing that I recommend is stronger consultation with and implementation of geologists in engineering projects. This is at the residential, commercial slash industrial, and government scales. Now, in Jamaica's context, we do have the Mines and Geology Division, and there does exist the, I would say, policy as well as regulation, whereby all buildings, along slopes should be granted approval by the Mines and Geology Division, and in some respects as well, before any form of construction is to take place, the relevant municipality for the specific parish should be consulted, and the engineer provide the go ahead in writing. The thing, however, that I can say, especially from my pretty much working with and collaboration with fellow professionals, is that there exists too much of a gap between the professional engineers as well as geologists in Jamaica. And in the context of engineering projects, notwithstanding that you do have the few that have their, I would say, in-house geo-engineers or geotechnical engineers, there still exists that form of a gap in terms of proper consultation with a geologist, having the proper implementation of, I would say, a more recent and uh, deeper geological survey, not just based on, let's just say, geological maps of 20 plus years ago, and surface geological maps at that, at a scale that is not relevant to the engineering project. But we're talking about geological surveys that even go towards the subsurface, and basically that is specific to engineering projects. We're talking about, high scale in terms of the maps that are to be produced. And the kind of insight is structural as well. These are just some of the minor points that I want to raise that the geologists can provide with or to the engineering project on a whole. So whether you are, a person who wants to just build a house, or it could be you, say for example, are the NHT, or it could be that you are the NWA, or pretty much it can be a case that you are even the JDF themselves, who have their engineering core, consulting with geologists who can provide you with the geologic data that is specific to the bedrock, specific to the location of faults, active faults, specific to the location of, let's just say, the drainage points or the surface water hydrology, and even the subsurface water hydrogeology, giving you insight in terms of the overall geography and other key contributors or key factors are critical towards ensuring that as best as is possible, the landslide mitigation is at its highest capacity. This is very significant, especially in the context that the reality we're facing as regards to much more intense rainfall, basically us having it be a case that we're having higher surface temperatures because we're talking about hotter days, and we can talk about pretty much it being a case that we can even have a higher degree of difference between the hot time of the day, cold time of the day. All of these are factors that are contributing significantly to faster weathering, faster erosion rates, and in essence, it means therefore that the lifetime of whatever engineering practice basically is being shortened. So, a lot more work, collaborative work, continuous work, paying attention to the geodata is critical. That is basically where I'm going to leave it for now. Hopefully, I can continue this in my other elements of the series.